So there is no coding here, but I will talk a lot of business problems I did face working myself personally. So I do work in Aspire Maritime. It's a company which tracks ships and vessels over the globe. So you can think that Luxembourg has could be a maritime country actually. So the problem we had, not problem, like the very typical use case is that customer asks us, where is the vessels? Like they're searching for the vessels over the globe. And they ask give us vessels in South China Sea, give us vessels in Atlantic, give us vessels next to the port of Rotterdam. It's a very common request from them. And they, very often they provide a polygon, so they ask where they would like to see, would like to find the vessels. And we, giving this polygon, we do a search. We use we use a lot of different systems, and most of our systems was actually with Elasticsearch, which is a search database. We also do have a relationship database like PostgreSQL, and sometimes we do in memory search. It means that we have a stream of events about, I don't know, we update the position of the vessel, and we filter in memory. So we filter just, okay, if vessel is in this area or not. If yes, return to the customer. If not, then reject the stream. So we do handle with the stream. And those three data sources are really different in terms of the technology, how they work. It also could be different languages too. Most of them, our services in Golang, but we also do have Java for a lot of things too. So I mostly work with API. So I do maintenance, customer complaints, API design, error handling, and validation. It's my part of the job I'm doing. And we have a lot of issues with the customers when they send incorrect polygons. And all those issues were ending on my side. Usually it's on my table and I have to fix it. So I decided to solve it once for all and kind of develop sort of the polygon validation library, just to, if customers send something incorrect, I reject it. So one of the things is that this thing was already working, so I have to implement things gently, one by one, so not do things in front or strictly everything. So this is my story, and as a former front-end engineer, I thought that usually validation is a simple thing, if you work on on the front end, you have an input to validate, and usually you go to npm or whatever, you found a nice package, credit card validation, for example. There is a package for this, which already does all the job for you. So you okay, it should be easy. So it's what I was thinking too. So I was thinking, okay, it should be easy. It turned out to be not easy at all. So if you know this meme from the Rick and Morty, when they go on the adventure, so it's supposed to be really easy, but then in the end they're crying and why I'm doing it to myself. So it was the same for me. I thought it would be a really easy task for 1 or 2 evenings, but it turned out to be task for actually several months and almost maybe 100 of PRs overall, spent in a long time too, and I felt never-ending task. So the talk will have 2 parts, maybe 30 minutes in total. So what is actually polygon in this context what I'm talking about? As I told, it's some area on the globe which customers are interested to see vessels. Most often they are looking for the port areas. For example, here in the center is the port of Rotterdam, and customers just interested in everything, all the vessels which are in this proximity. A very common case, give us all oil tankers in the port of the Singapore, because port of the Singapore is the big oil hub. So sometimes customers are interested in the economic zones. For example, here in Philippines is a part of the economic zone, and they are looking for the shipping or fishing vessels over there. Sometimes it could be even bigger, full seas and oceans, and it could have really elaborated or complicated, a lot of points to cover all the shorelines. So this is polygons I'm talking in this talk, and there is a little bit of terminology to cover. So each polygon has a line, a boundary. It's called exterior, and content of it is called interior. Polygon is allowed to have holes, one or multiple, no problem, could be any kind of them. Sometimes polygons are kind of go in a package, and it's multi-polygon, so it's basically composed from from single polygons. It could be actually multi-polygon of one polygon, but could be multiple of them. Could be multi-polygon with holes, even multi-polygon with a polygon inside of it, if you want. So but this is too complicated. Normally we have usually polygon, maybe polygon with hole, and something like this. It's the most common cases. So how this thing is sent to us? So there's two standards. One is called VWKT, or encoded as a well-known text. It's an old standard, and this polygon is like, in the standard, polygon is encoded as a single string. So the polygon is over there, example, and yeah, how it's encoded. The second is a little bit more modern standard, is a GeoJSON. So it encodes polygon in a pure and nice JSON. Customers send us both of them, it's like 50-50. There is no, no prevalence. It depends of their origin or how they design, so it could be both of them. And we accept them all together. For the sake of the presentation, I just wanted to show you how holes are encoded. So when you have a polygon, so usually the first set of coordinates defines a boundary, this one. But then if polygon has a second line or third right line and so on, so each second thing is basically a hole. We will counter a little bit later too. So those are two different formats, and they have their own quirks and specifics. So they were designed independently in different time, and they have different standards. So for the sake of simplicity, we kind of accept only inputs where we can convert from one to another. So there is some VWKT which could not be converted to the GeoJSON, and we say like, no, we don't take it. The same about GeoJSON. There is some specific, but less. So we take only where they are basically could be converted from one to another, and we treat those two standards as equal, but they're actually not equal. So if you go to really details, they have like specifics, but we are simple people. We don't want to have too much complexity for us. And I think it's quite common standard. Like if you design if you have front-end application, when you design an input which accepts some geometry, you probably will take the same route as we are. Don't dealing with any specifics. So customer sends us input. So how we validate is the correct one? And as I was thinking, simple question. It's actually hard to answer, because there is no fixed defined set of rules which make a correct polygon. You can think about it should be closed. It's a good guess. So I decided to look at the standards actually first, and VWKT is just a syntax, so it does not tell you anything about how polygon should be correct. For VWKT, for example, you can create polygon with one point. It doesn't make sense, but it's syntactically valid, so it's allowed. So GeoJSON actually have some rules, and I will cover them later. But what we personally discovered ourselves is that you have to go further and think about what the rules are important for your business, because what's important for us could be not important for you, and vice versa. Second thing I learned is that those kind of like the geometry input is really complicated. There is so many ways how customer can screw it up, and I show you a lot of examples. And it's hard to validate, but also hard for customers to provide it you correctly. So they will send you any possible shit you can imagine. That's absolutely. Databases, surprisingly aware about it. So the search engines like a PostgreSQL or Elasticsearch, they know about it. So they build with a high tolerance. As I told you, originally we did not have any validation. So basically everything was coming, and we were relying on the search engine to reject it or process it. But because of the quirks and complex geometries, we cannot guarantee results. For example, we had a case when the same polygon was yielding to different results for the Elasticsearch and for PostgreSQL, just because of the quirks of the databases. But they will not send you an error. They will accept almost any gibberish which customer will send. So, how we approach the problem? First, so GeoJSON specifies that polygon should be closed, which is cool, having at least 4 points. So for GeoJSON, it's really important the first and the last points are the same, so they make a closed area. We'd be surprised sometimes customers do not send it. They think the polygons should close themselves. So another thing is the coordinates. I will talk a little bit later, but GeoJSON strictly specified that we limit ourselves to the coordinate plane from plus 90 to minus 90, south, north, south, and then east, west, minus 180, plus 180.
Where the free?
It's a part of the stuff I will talk about later, but it's how you can make it free. You actually can make it continuous to have like 250 longitude or minus 260. It's possible, but it's a different coordinate plane. So GeoJSON say like we have to stay strictly like you had map on the school. You had map on the school, so the paper was over, so you cannot go further. You go back from another side. But you could imagine map goes and repeats to infinity. It's also possible. It's just how the specification says. We strictly, and it plays the role. Here's the new concept, really important. It's a winding order. So when you have points, you can traverse them differently. So for example, in this case, you go clockwise. So 1, 3, 2, and then you make an area. But you can do otherwise. So you can 1, 2, 3. So this traverse order actually does not change the area behind the polygon, but it makes sense how the polygon traverses. And GeoJSON set the rules for this, that each polygon have to be interpreted in a, so the boundary of the polygon always should go counterclockwise. And if polygon has a hole, then coordinates should be traveled clockwise. It's a bit hard concept to grasp, but we will also come back to it later a little bit. It's important. And like first, when customers do not care, it's too much complicated. Basically for the customers, they don't really care how you traverse the polygon. The area for them is the same. So they actually send you whatever, it's like 50-50. It could be in any. So there is a formula where you can determine how the polygon should be traversed. And it's also about the order of the coordinates. So first I implemented validation rule for it, but I actually realized that if I apply it, I will drop I will cut half of the customers. And this is like not acceptable. So we have to, actually there is a rule to fix it on the fly. So how it look like? So the first polygon is invalid, and it travels the clockwise. So this is wrong. So according to the spec, polygon should be traveled counterclockwise. So the points 1, 2, 3, 4. And to solve the problem, you just need to run a reverse algorithm. So you need to basically swap all the positions. So the first and the last stays the same, middle stays the same, and just 2 coordinate swap. But if polygon is bigger, 9 or 10 points, you just run a reverse. So customers send us polygon, and we just run it through the reverse algorithm if needed only. This is important, will be for later. It's kind of soft validation rule we have to implement. So what else? Those rules are not from GeoJSON, but it's something we discovered ourselves. For example, sometimes customers send us self-intersecting polygon. Is it like okay, not okay? GeoJSON does not tell you anything about it. We decided it's not okay. It's ambiguous, so we cut it. Sometimes customer make a mistake or misarrange coordinates. So for example, this one, 1, 2, 3, 4, 5, 6. So this area collapsed to the empty space. And we don't, it's also ambiguous. We cannot guarantee predictable result from this case. Also, dropping. Sometimes they send empty geometries or empty space, just too small. So we have to go further, and this is more like business rules we develop for ourselves. Then it comes a complexity in terms of the size and the number of points. Because we work in the maritime, too small, we are not operating polygon size of the door. It doesn't make sense for us. For us, when it's basically 1 square meter, it's totally fine. Even 1 square meter is too small for the vessels. We usually need like a little bit more. So we decided, okay, let's drop 2 small polygons. Sometimes they're happening. Sometimes customer sends us like so many coordinates, precision, like I don't know, 10 or 15 points over there. So we also kind of rounded them. Very often they send 2 versatile polygon. You know, they send so many points, and we have to actually run the analytics over the long time to say like how much is enough. Like it's okay to have 20,000 points or 30,000 points, because the more points we have, the complex search becomes, but also the complex validation becomes. So it's tricky. We decided to limit to 20K points for ourselves. And what next? So next, sometimes polygon could be absolutely valid overall, but then it comes to the holes. And this is where customers, they don't really know what they're doing very often, because the input is so complex. So this is a typical case. Customer sends a request and complain, I'm not getting data from the South Korea or from the Korea Sea. You look on his polygon, you draw it, and then you actually realize, so the first polygon is a boundary, the first part. The second part is a hole, actually. So what customer did, he took 2 independent polygons, composed them, and he thinks that this one will behave as a multi-polygon. But in reality, it's behaving differently. It's behaving like polygon with a hole. And what he did, so he has polygon here, but then he put a hole over here. And the hole is empty space, you know, like basically a hole makes sense if it's here, but hole outside of the polygon itself is empty space. Yeah.
Question: how do they draw these polygons? They like input them by
Listen, they sometimes, like, I mean, this one I believe he just composed in a text editor.
Yeah.
Sometimes they copy them. There is like catalogs of the polygons. Sometimes they copy them from those catalogs. Sometimes they just have a libraries of the polygons themselves crafted by someone. Sometimes they just, as I said, they take those things, compose them with the mistakes, and send to you. So there's like multiple. It's up to the customer. We don't really know, but from number of the errors I could see, they do it like without double thinking. You know, they just compose it like in this case. It's a super obvious mistake for anyone to understand that, you know, that you're making polygon with hole, but customers, they maybe not possess knowledge in such a geometrical thing. So he was thinking that, okay, I compose 2 lines of coordinates and it will be a multi-polygon, but actually not.
Is it just easier just to give them a library of your own polygons?
Each customer is unique. We do have our library of polygons for example, for ports, if they need it. But as I say, each customer is unique. They have, for example, like a customer could be operating only in economic zone of South Korea, so he has his own collections of the polygons. And most, like some of them are crafted correctly, but sometimes it's just incorrectly. Or they need to modify it and compose them somehow, and they just do silly mistake. And the thing is that this thing is absolutely syntactically correct. So this will pass any syntactical validation, but it's logically incorrect. And even if I implemented all the previous rules, I have to always go further because it was always some next customer making some new interesting mistake, and I have to solve it. So when I implemented rules about complexity, I had this case and I realized that, okay, I need to implement more rules about dealing with holes. So I have to forbid that there should be no holes outside of the polygon. So the holes should not intersect with the polygons itself and will not intersect with each other. Sometimes customers send you a polygon and the hole, which is bigger than the polygon itself. So it seems that he confused, he swapped. What should be polygon become a hole and vice versa. And like when he sent this thing, it doesn't make sense at all. And he does not getting correct results, of course, and he's complaining in the end about the results he's getting. So if you validated polygons, then you have like maybe like 90% of the job. because validating multi-polygons is way more easier normally, because you already validated. So the single case is when you have a polygon, multi-polygons are overlapping. It's not a big problem, but like I decided to work on this and basically merge all the overlapping things, just to have a good, like just not to think, okay, how database will behave if some polygons overlap. But again, we have a customer mistakes when they're actually composing polygons together, and they do the same similar mistake. Real case. Customer has this 3 polygons over there, composed as a multi-polygon. And he's complaining again, he's not getting too much data as he expected to have. So I look on this, and so basically it's how it normally looks. It's a little bit hard to read. So I decided to make it simpler for you, and the customer basically did the same mistake again. So he took several independent polygons and composed them, this time correctly, into multi-polygon. But again, he did not think it fully true, and he actually created multi-polygon of a single polygon. And first one become a boundary, and last 2 become holes. But because they are, so like this one become polygon, and those 2 become holes. And because they are out, they are empty space, so they doesn't make sense. So we have to, I have to fix the polygon for the customer, so I have to put braces correctly to say okay. And then I have to send it to him like, listen, this is the fixed one, so please use it. So finishing the first part, I can say that I have to implement a lot of those rules, and because on the Golang I have to actually, so there is libraries in the Python and JavaScript, but for the Golang is not so much. So I have to actually dig a little bit, copy the codes, understand a little bit of computational geometry. It was a little bit painful. Some things you actually can fix on the fly, like a winding order or some duplicate coordinates, for example, or merging. It's like could be helpful, but it doesn't change polygon itself, just make it more standard, I would say. So the second part is how we cross the world. So the coordinate plane is normally like this. So I already told, so you have latitude and longitude. And so this is line when the longitude is 0, it's called the meridian. It goes through Europe. So from this point it goes negative, from this point it goes positive. And the opposite line are called anti-meridian. So basically those 2 lines are the same, so they're both anti-meridian, and you are like, if you're crossing here, you're entering here. So this is how normally, and it's called non-continuous coordinate plane because we bounded ourselves together. So the question for you, could we have polygon like this? So could a polygon across anti-meridian, and how do you encode it? So it's a very tricky question to answer. So let's, before answering it, so let's have another question to you. So
it will be always a polygon, multi-polygon created from 2 halves, and probably that will be the
yeah, we'll come there. But before answering it, it's another polygon from the customer. It has just like 4 points. But I just draw the points, not the area itself. So you could imagine area. So you could, like in your mind, you could connect 4 points. Yeah, you could imagine it, easy. Now I draw the same 4 points, but from different perspective. Could you connect them too? Yeah, easy. But they are actually totally opposite. So they both, these 4 points, depending how you connect them, they create totally different areas. So this one that you saw first spans over the globe, and second you saw on the Earth, it spans over the Pacific. So which one is correct? You have 4 points, but how it go? It go like this, or it go like that? So who supports variant A?
Should be the winding order
I'll explain it. So just for the moment, so let's who for variant A. So the raise a hand.
No.
Okay. So variant B, who is confident?
Who needs supplementary information. Both of them are.
So okay, keep your variant in mind, and so let's answer for this thing. So in this case, this polygon is ambiguous. Why it's ambiguous? Because you have a situation when a shortest, so you have 2 points, but the shortest path between them crosses anti-meridian. And in this case, you're like, okay, I could interpret it like this, or I can interpret it other way. Like when you have polygon like this, it's easy. It does not try to cross anti-meridian anyways. It's easy to interpret. It's obvious. It's clean. It's clean what area it will cover. So it's not ambiguous. The one we had there is ambiguous. It's not really good. And if customer sends you ambiguous polygon, it's kind of okay. What he meant. It's a tricky question to answer, and sometimes customers do this mistake very often. They send you one polygon. They think it will cover this area, but it will not work as they expected. I will show examples. So the answer is actually depends. It depends on your search engine and on the coordinate plane you decided to use, or like what coordinate plane your search engine is using. So, for example, as I do work a lot of Elasticsearch, there is a rules I discovered hard way. So, if polygon is bounded correctly, so the points go in a counterclockwise order, polygon was treated as a normal polygon, and it will never cross anti-meridian. So it will always go nicely within the -180 +180 coordinates. But if it's winded differently, otherwise, so the Elasticsearch treated as a kind of anomalous polygon, and for this anomalous, it's allowed to cross. So the same points. So this is like polygon, but I changed the winding order for them. You don't really notice that like some coordinates is just swapped each other, but like they could cover some different area, and depending on the sort. So the PostgreSQL is very strict on this. No anti-meridian crossing in any circumstances. So nothing. So the answer is actually A, most of the time. Most of the time. But it could be B, depending on what search engine you're using, how library for interpreting polygons works. Sometimes the library actually could accept those things, or so it's possible. It's not strictly it's how you set up your system mostly, but normally it's this thing. And according to the GeoJSON standards, that's why GeoJSON putting such an emphasis on the winding order. So according to GeoJSON, crossing of the anti-meridian is not possible. And the solution, the right one, is what you tell, is that you need to do yourself, or customer must to do anti-meridian cut. So they need to take a polygon and cut it into pieces, creating multi-polygon along the anti-meridian line. So cutting this way, you're cutting ambiguity. So in this way, the polygon is obviously interpreted. There is no shortest path between points which crosses anti-meridian. So done this way, it will be clean and obvious for any system that will interpret it in the same way everywhere. And but as I told you, it's not very often how customers think about it. So example, SpaceX is one of our customers. They send polygon. I draw points for you again. Somewhere around Hawaii. I don't know, maybe they want to see where the rocket is landing. I have no idea. So this is like points. And you can think, okay, they probably want to cover this area. But the problem, the anti-meridian goes next to the New Zealand. And in reality, their polygon will be interpreted totally different. It will wrap around. So they will get any data possible except in New Zealand. Of course, they get some bizarre. And it's a very common case. The customer think it should work, but it will not work this way. Another very common case is in New Zealand. So customer wants to search vessels around in New Zealand. So he sent the polygon here. But here is anti-meridian, so we get inversion. So we get everything except New Zealand, which is not obviously what they wanted. Okay, so wrapping up slowly. For us, so we decided to limit customers to say we never allow to cross anti-meridian. So we cannot accept randomness in output. So we need to set really clear rules that things will be interpreted this way. And as I told you, it's a matching with the GeoJSON standard. But for customers, it's a trouble because sometimes they think like, it should go this way, why it's so complicated? So what I did, we cannot reject all those polygons, what they think is should write. But what we did, we started to calculate this ambiguity. So it's possible to calculate that, the shortest path go through anti-meridian. And when the customer sends this ambiguous polygon, we return them result, which could be incorrect for them. So it could be what not they think. But we also return them a warning altogether that we're saying, listen, your polygon is going like this, and it's not cross anti-meridian, so be aware. And it's actually helped a lot. So a lot of customers, when they get the warning, they're like, okay, we'll see. And they started to do cut themselves. We have like really a lot of polygons decreased in terms of ambiguity. I think right now we have a single customer who is reluctant to do so. So closing the talk, geometry is very complex input for customers mostly. So it's hard to deal with them. They do mistakes, they do errors. It's interpreted differently, as I showed you multiple examples. But it's also for you hard to validate. You're lucky if you have JavaScript or Python. This will be easy. I was less lucky with Go. So then work with ambiguity. Try to remove as possible to have really obvious interpretation of the polygon, like which area it will cover. So limit the coordinate range, winding order, and anti-meridian crossing is the most common things of ambiguity. Really a lot depends on the data source you're working, like Elasticsearch, so you need to know how to deal with some edge cases. As I told the customers, don't really care about anti-meridian, they just wanted work, but it does not work as normally. So that's all, so thank you, and I open for questions.